Welcome to the Real Python Podcast. This is episode 121. What's the big breakthrough for natural language processing that has dramatically advanced machine learning into deep learning? What makes these transformer models unique? And what defines attention? This week on the show, Jodie Burchell, developer advocate for data science at JetBrains, continues our talk about how machine learning models understand and generate text. This episode is a continuation of the conversation in episode 119. Jodie builds on the concepts of bag of words and word-to-vec and simple embedding models. We talk about the breakthrough mechanism called attention, allowing for parallelization in building models. We also discuss the two major transformer models, BERT and GPT-3. And along the way, Jodie continues to share multiple resources to help you continue exploring modeling and NLP with Python. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Jodie, welcome back.
Thank you. I'm very excited to be here again.
Yeah. We're going to continue our conversation. We dug pretty deep into the first sort of two techniques of understanding text using these data science techniques, and then also giving people lots of resources for doing that with Python. And now we're kind of building on top of those two techniques of, it was a bag of words models and then sort of word to vec. Yeah, ready to dig into our next level.
Yeah. Where we left off with word to vec was that we were taking every single word in a set of documents and converting it into a vector. And some of you may have been wondering, well, what happens when a word has different meanings in different contexts? So let's say something like a riverbank versus Bank of England. Well, the problem is, as much as I love my wonderful word to vec, it's a bit stupid on that account and it can't tell the difference between them. So all meanings of a word will just be collapsed on the same token. And this can obviously cause problems when those meanings of the word are quite different. So not always the best. What the newer models are attempting to take into account, and we're talking now about the current generation of models that are being used, is the total context for a word in a sentence or a paragraph.
Okay. So going beyond this like little window that we were doing inside word to vec, which was maybe the 3 or 4 words that this word is around, more phrase like. Now we're kind of going into like a full sentence or more.
Yeah, exactly. So let's take like a really classic example. So let's say we have the sentences, I want to go to France at the end of this year. I was thinking of enrolling in some courses and picking up some new skills. So now I want to learn. What would you complete that as, Chris?
How to cook. That's why I would go to France.
True, actually, true. So what we're hoping the model would predict is French, though. But, maybe the model is tricking me.
Right, yeah. That's example. Good. Yeah, I want to learn the language, yeah.
So obviously, you kind of need to understand the context right from the beginning of this sequence in order to infer that we're trying to get that, prediction of French, or learning to cook could also make sense. So the original approaches tried to basically go along a sentence or a paragraph word by word in the exact same way that you would read it left to right or right to left, depending on the language, and kind of like develop this little memory for what the model had already seen. The hope would be the model could remember this French this France that I'd seen right at the beginning, and then go, okay, I need to output something related to that. And, the logic was sound. These original models called recurrent neural nets, and then there was a sort of special version of those called long short-term memory models. But the problem is, in practice, they didn't actually work that well. And there were two reasons for this. The first is that after around 20 words, this memory started failing in the models, and pretty much information from the beginning of the sequence was forgotten. So in this phrase that I said, it definitely would have forgotten France by the time it got to the word that it needed to predict. And it would probably be like, I want to learn to swim or something.
What I'm trying to think of why it's losing that. What is it that it is it the amount of actual quote unquote memory, or is it just it got too complex thinking about all the contexts of everything coming after it that it lost all its meaning?
Yeah, it's for a very technical reason, and I'll sort of try to explain it in a simple way.
Okay.
So basically, these models, they have a lot of different layers, and you sort of do transformations of the data at each layer. And these particular models were using a transformation that sort of squashed the data. And it meant that the deeper and deeper these models got, as you sort of tried to send data back through in order to train, it just got so squashed that there was no signal anymore. It's what's called the vanishing gradient problem. And the complexity of the model was just kind of too big, and, you just couldn't send information all the way back through and set the weights properly. The other reason, actually, though, that these models kind of lost popularity was a practical reason. You can imagine, because you're processing sequentially, you can't actually scale that well, because as the length of your sequence increases, your processing costs and times also grow, and you can't parallelize that entire thing. So you can imagine you're trying to feed in these huge sequences and train these really big models. It's not very attractive.
Okay, so it can't, the advantage of parallelizing, I always mess that word up.
Me too.
I missed the extra L in there. The problem is that it has to keep all of that in one process to know its relationships. It could potentially do, a paragraph over here, a paragraph over there, but they're not going to necessarily be able to share the context with each other.
No.
Okay.
No, they can't. So this is, a pretty huge problem, especially when you start thinking about the size of these models and the fact that the reason we've been able to get a lot of gains with deep learning models is because of this parallelization in training. So there was a paper that came out a few years back called Attention is All You Need. And this basically rocked the natural language processing community to its core. What it proposed was a mechanism that's called attention, was already known, but it sort of proposed using it in a new way to basically solve all of these issues and create models that can learn about the context in which words occur, but in a way that can be parallelized. So I'm going to give a very dumbed down explanation of attention.
That's totally fine. Yeah, sure.
I think it's for the best.
To keep people paying attention.
Oh God, I went through so many iteration of this, guys. I tried my best to explain it, and I'm like, you just can't. It's just, maybe someone more clever than me, but I couldn't. So we're going to do a really dumb version. So basically where we start is with these same word embeddings, like the ones that Word2Vec created. So every single word starts with a single word embedding. But then what we do is we start adding in information. So the first bit of information that we add in is a weight to represent the position of a word in a sentence. So obviously we're looking at an input sentence here. I should clarify that. And then what we do
An import sentence. What does that mean?
Oh, input. Sorry. So
input.
We're looking,
okay. Sorry.
Yeah.
Okay.
No,
okay.
no.
So,
accent. Yeah.
That's right.
Yeah. So we start with this sentence. We have word embeddings. So these vectors from Word2Vec for each one.
Okay.
And then basically we then add some information. So we weight those word embeddings based on where the word sits in the sentence. So you can see already we've got more information than we would have with a simple word-to-vec model. But where the attention mechanism comes in and sort of where this sort of differentiates from something like word-to-vec is what you do is you generate weights for each word in the sentence to represent how much its meaning or grammatical form is dependent on other words in the sentence. So it's a bit of a weird concept, but...
No, I'm kind of grabbing it in the sense that it's like grammar. If this is the subject of the sentence versus the, the verb or, the different kind of components, like if this is just describing the other words, like, the sort of relationship between the words do give them more power over one or another, depending on how it's put together. If it's, depending how it goes back to diagramming sentences.
Yeah. Exactly. And you can basically represent these relationships between words in, just a matrix of values. So it's like for the first word, it will have the amount of attention it needs to pay to all of the other words in order to gain its meaning or grammatical form, and so forth for every single word in the sentence. And then you basically combine this information about the word embeddings, the basic meaning of the word, its position in the sentence, and then how much it interrelates with all of the other words in the sentence to have its final meaning, to get a final representation of that word within the context.
Okay.
You basically train these models in different ways. We'll kind of touch on a few different ways with BERT and with GPT. But the general idea is over many, many training examples, the model starts to not just internalize words, not just internalize word meaning, but it starts to internalize rules of language that we understand when we read. So this is sort of like what I was talking about. These models are iteratively over time gaining more and more of that internal understanding of what language is conveying when we read. It's pretty cool. It's again almost like magic, but it's not. It's just math.
Yeah.
Yeah.
Well, in the sense that it sounds like the models are not having a single training session. They're being sort of retrained and kind of, almost like an athletic regimen.
Yeah. Actually, it's a good way to think of it. So to kind of give like a bit more of a step out and context about how deep learning models are trained, essentially all they are is like a bunch of interconnected layers. And the layers are, the connections between the layers have weights. So if you ever see like model weights referred to, that's what it is in a deep learning context. So pretty much what happens is you start at like when you start training a model, you just set the weights randomly, and then you get the model to go through and like try and predict something, and then it'll be wrong, but it'll try and work out, okay, how wrong am I? And then it'll basically adjust the weights, try again, adjust the weights, try again. So that's all these models are doing. Their internal representations are just weights.
Cool. Yeah. So that makes sense. That it's nice that there's this flexibility in there then that is allowing it to expand in some ways, grow its muscles, if you will.
Yes. Yeah. So it's becoming a real language model.
Okay.
Yeah. Okay. So I don't want to kind of spend too much more time like going into deep theory, but the kind of thing that you need to know is that attention is the basis of what you'll see called transformer models. And this is what you'll see this current generation of language models called. So it's just a particular way of putting together deep learning models in a way that, is based around attention. So the ones that I want to talk about are BERT and GPT, as I said in the last episode. But I think you alluded to the fact that we have like a few really fun names.
Yeah, definitely. Especially for the BERT ones.
Yeah.
They're having, I guess this is the one chance us science people get a chance to play around is in naming. So.
And that's the thing. I can actually tell you, like, from my time doing academic research, if you can come up with a good acronym, you are king, man. Like, people love that. So I can imagine there's
That's funny.
competing with each other. Cool. So let's just kind of talk quickly about BERT. So BERT basically is a general purpose language model. And it's kind of designed to be like a Swiss Army knife of language models. And you can use it across many, many different tasks, such as, I don't know, do you want to detect if a sentence is grammatically correct? Do you want to detect if question and answer pairs go together properly?
Okay.
Do you want to detect,
So I can think of like right away real world uses, things like Grammarly or something like that.
Exactly.
A tool that actually is identifying things like that. Okay, cool.
Yeah. And BERT was kind of the first of the transformer models to really get like mainstream recognition. It was the first one I ever played with. And
who created this one?
This one's from Google. It's a 2018 model.
Okay.
It's funny now, like BERT was such a big deal when it came out, and now it's such a titchy little model compared to like some of the stuff that's being used, but it's still like a really important and very accessible model to use. And I'll talk a little bit about, or in a little bit, I'll talk about how you can use it yourself.
Okay, nice. It's not walled off from the general users.
No, definitely
Okay,
not. Definitely not. So the other one I wanted to talk about is GPT. So as we talked about last time, there are three different generations of GPT models. So GPT 1, 2, and 3. So GPT is not a general purpose model. It's a text generation model. And it was basically trained to generate the next word in a sentence. So
it's kind of the reverse in some ways. It required other tools before it to be trained and built, but its goal is to actually output text as opposed to analyze what's coming in. Well, I mean, I guess it kind of goes both ways. You got to prompt it.
Yeah, but it's funny, like text generation is like such a distinct task compared to, I would say, more traditional machine learning tasks. So like classification, it's really like, okay, BERT can do that for you.
Okay.
But GPT, it's very weird thinking about like text generation in the sort of context that I'm used to thinking about machine learning. It's a very other sort of task.
Is that where the names kind of come in? Because BERT is what? Bidirectional representation of text, and then GPT is that the generative part of it, pre-trained transformer? Okay.
Exactly. Yeah. And BERT's also, its name comes from how it was trained. So basically it was trained in two ways. It was trained to detect and try and predict a missing or masked word in a sentence.
Okay. Like you were saying, the France trip.
Yeah. Exactly. But what they try and do is mask words that are in the middle of a sentence. So like say you had two sentences, this masked is called Henry. He comes from Sydney. Then basically BERT will need to use like quite a lot of information there. So he'll need to use, not he, BERT is not a he. The model will need to use.
Could be Roberta.
Could be.
Right.
It could be Roberta, could be Albert, could be Camembert. But you can see that, the masked word doesn't occur at the end of the sentence. It occurs sort of as the second word. So BERT would need to say, okay, there's words on either side, and also there's a he in the next sentence. So, there's a good guess that the missing word is man.
Okay.
So, yeah.
It's like intelligent Mad Libs.
Intelligent Mad Libs, exactly.
Yeah, all right. This week, I want to shine a spotlight on another Real Python video course. It's about a segment of data science involved in making predictions based on data. It's titled Building a Neural Network and Making Predictions with Python AI. The course is based on an article by Deborah Mesquita, and in the course, Douglas Starnes takes you through how both machine learning and deep learning play a role in AI, how a neural network functions internally, what are weights and vectors, how to reduce prediction error, and how to build a neural network from scratch using Python. Like most of the video courses on Real Python, the course is broken into easily consumable sections. You get code examples for the technique shown. And all courses have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com.
I kind of wanted to give maybe a bit of a taste of how far, these models have come over, the last few years. So
yeah, that's what we started with in general, like the idea that, is this thing sentient, this chatbot?
Yes.
Yeah, okay.
Yeah. Okay, so little story. So this job that I was talking about in the last episode at the job board, I was very lucky to work with a lot of computational linguists, so people who were super, super interested in language. And you can still actually access this endpoint. There's a company called Hugging Face, and they have this endpoint where you can input like sentence fragments or prompts, and it'll use a bunch of different models, including GPT-2, to generate text for you. And the thing was, GPT-2 is great, but it has some limitations in how it actually generates text and detects the meaning of the prompts that you input. So let's take an example of a prompt that I put in. So, why do you want this job? So it's kind of a typical interview question. It has certain implications. There's a certain context. And what GPT-2 gave me is, I'm a little frustrated about how hard it is to make your own money. Like, okay, like grammatically, it makes perfect sense, but you would never say that.
I mean, unless you're
context.
I'm trying to think of the term. If you're going to print your own money.
Yeah. You're a criminal.
It is kind of hard to actually, quote unquote, make your own money.
Yeah. I'm interested in stealing money.
Yeah, exactly.
What have you been training on GPT-2? But
let's just cut right to the idea of printing it.
Exactly. But in contrast, GPT-3 also has an endpoint, FYI. You can also play with that. And I'm going to share both of those links so you can play with this yourself. So I put in the same prompt and I got absolutely beautiful pat answer. I want this job because it is a great opportunity to use my skills and abilities to make a difference in the life of others. There you go. There you go.
Top of your resume.
Exactly. But really the difference between these models is it's just the size of the data that's going into them. And this is sort of, I guess, the potential for these models. But I will talk about limitations as well as these models grow. One thing, though, is I decided to see if GPT-3 can actually detect humor. So I said, tell me a joke about data science. And it said, why did the data scientist break up with her boyfriend? And the answer was, because he didn't understand her love for big data. And I was just like, it's funny, but not for the reason that you think it should be.
Wow.
Yeah. So
there's a artist, musician, and I love that he actually decided to name his project Big Data.
Oh, nice.
And it actually has some pretty good songs out there.
Well, maybe that was what happened.
Exactly.
It went over my head, GPT-3.
Yeah, you missed the connotation in the musical context.
Yeah, damn it. Outsmarted again.
That big data? Oh, I didn't know we were talking about individual.
Yeah, damn it. So this leads me to how you can use these models. And this is actually a very interesting kind of conversation and debate that's coming up. BERT was trained, as I said, in 2018. At the time, it was considered a model that was sort of prohibitively expensive for individuals to train. So it used around 3 billion words. Apparently, it took 4 days on 64 tensor processing units, and it had an estimated training cost of $7,000. So you can imagine, now that's going to be a lot cheaper, but it probably still talking like several $1,000s to train your own model like BERT from scratch. And most people don't have that sort of money. So now we're sort of entering the territory where most people are not going to be training their own transformer models from scratch. And this is where companies like Hugging Face come in. And this is where you can get your hands on transformer models and actually start using them. A lot of the models have been publicly released. Hugging Face is by far and away the best way to access them. So pretty much the way that most people do this is you take a pre-trained model, so one that Google or Hugging Face or OpenAI have trained, and what you do is you decide what you want to use it for. So it could be for text classification, it could be for grammar detection, whatever you want to use it for. You just need to have a data set that you can fine tune it on.
Okay. So it's not necessarily going to be a generative thing. Like you could still be analyzing your projects and your text if you want.
Yeah, exactly. And this is why I wanted to stress, like, BERT is a general purpose model, and it's, by no means the only one. And there's also there's smaller versions of BERT that you can use. So, you're not limited to using these enormous models. Basically, the advantage of fine-tuning these models is pretty much what it does is, remember how I said that neural nets are basically a whole bunch of interconnected layers?
Yeah.
Yeah, pretty much what you do is, or you don't do it, the package does it for you, is it adds an additional hidden layer to the end, and it just has random weights. And you train the model to do the task that you want it to do. So you'll basically be like, here's a whole bunch of news articles. I'm going to pass them through the model, and I want you to correctly predict whether it's a sports article or whether it's a crime article. And then basically it'll adjust the weights, and pretty much people say that it takes about half an hour. You'll have a model that's tuned to your purpose, but you can harness kind of all of that knowledge that BERT or similar models have learned about how language functions.
Okay. So that's the training session.
Mm-hmm. Mm-hmm.
How many pieces of material would you need to provide it? Because I would guess, the half an hour is the training on several, potential documents of input. And then actually running the model, doing prediction after would not take as long.
No. So it really depends how many you have to train on. But again, when you're at the point where you have these models that have already been pre-trained and they've already learned huge amounts about language, in advance, the amount of data that you actually need for fine-tuning is a lot less.
Okay. You're harnessing the work that's gone in that whole
Yeah,
you're
exactly.
You're able to pick somebody who is already an athlete and now you're going to say
standing on the shoulders of giants.
Yeah, it's like, okay, I have this athlete and now I would like them to play soccer, or I'd like them to play baseball or whatever. Okay.
Yes, it's a beautiful analogy. And actually, if anyone in the audience or you, Chris, are interested in learning more about this, there was this fantastic and very timely talk at a conference I went to a couple of weeks ago. So basically, this woman was talking about the fact that with the growth of these models, it's almost like we're seeing a shift in how accessible models are to use.
Yeah.
And so we'll get to this with GPT-3 in a second. But part of the problem is, individual people can't be expected to spend a few $1,000s to train a BERT model. It's really not feasible.
Right.
But
or able to set up the machine to just do it.
Exactly.
Right?
And preparing the data even is it's not as simple as just
finding the words. Yeah.
Yeah, exactly. So she was pointing out that there was this paper that came out, which is called Standing on the Shoulders of Giant Frozen Language Models. And it's this exact same idea. It's amazing that we actually have these huge, very expensive, very powerful language models available to us that we can basically harness to our use case and then reap all the benefits of. So yeah, it's super cool. So shall we have a chat about how people can try this at home?
Yeah, definitely. We kind of glossed over the we talked a little more about BERT coming along, its history, and that 2018 was kind of the dawn of it. But GPT had been through several generations. I don't know the dates of them. I know GPT-3. You have noted in our shared document that 2020 is really the dawn of GPT version 3. Because I remember generative text being mentioned even 6, 7, 8 years ago, where they were like, let's see if it can write a science fiction script, based on these other documents and so forth. And it was terrible.
Yeah.
And and now we have tools that are helping us write code and do other things based all on this GPT-3 text, so that it definitely has moved pretty far along as we've gone along. It's no longer the butt of a joke.
Yes. Yeah. And I think this is actually a good segue to talk about GPT-3 and how much it costs to train. And I think we can probably dive a bit into Copilot and the discussions around that. So yeah.
We don't have to get too no. The worry that I think a lot of people have about, they're going to discuss machine learning and AI, and they're going to get into ethics and and it's going to become this big hand wavy or clutching our pearls kind of thing. And it's like that's not my goal. I feel like we want to this stuff is out there, it's interesting, and yes, any technology can be used good or bad, or it can be trained properly or improperly. So that's not really the discussion we're having here in this case. So we're much more interested in let's check it out. Let's let's play with this stuff and kind of learn from it. And then let you be the judge of where this can be a useful tool or not. And it's not like you're not going to see it. It's around. And so we're hoping that there can be some context that you can get out of this, and it's not all purely buzzwords.
Yes. Yeah.
And you can kind of see where all this, where a lot of this came from, and then hopefully give you chances to do more research on your own. I've been sharing lots and lots of rabbit holes lately as far as Python goes, in ways that if you really want to learn like the grammar of Python, things like that, because I find that interesting. It's weird. Like when I was in school, like I was very frustrated by the classes that I was taking in English that were like sort of research classes, and I think it was because of the way it was structured, and I had to do it in their specific way and on their specific timeline. And what I'm doing now is so much more fun for me, that I can kind of dive into all these different things. I can kind of bring people like yourself that have been studying this and ask you questions and kind of try to come up with analogies and ways to think about this stuff. And then, share places that people can continue on and go with this, as opposed to me sitting there in a library and collecting note cards and anyway,
gosh, yeah.
It's like the internet has come along and made all this way more fun.
Yes. Yes.
All right. Well, cool. So yeah, how do maybe you were going to mention two things there. One was we mentioned the training budget, if you will, for BERT. Do you want to talk about the GPT-3 thing, and then we can kind of go from there?
So GPT-3 basically, so I mentioned that BERT was around 3 billion words. So GPT-3 was 100 times that, around 300 billion words. Yeah.
That's a lot of words.
But basically, Microsoft custom built them, a special supercomputer. And I've seen estimates that it cost $5 million to train it.
All right. Yeah. Yeah. A big company has a chance to do that.
Yeah, exactly.
I mean, they might be testing lots of other things at that process too, and
yeah. But the thing is, the good news is you can actually still access GPT-3. It's just not as flexible as accessing something like BERT. So basically, the way that OpenAI are doing it, the company that developed it, is they have an API and you pay per usage. So they have basically a pricing system that's based on the number of words or tokens that you want to process. So it's not as open as something like BERT, and I'll talk about how to use that in a second. But
Okay.
you can still, through the API, fine-tune this. You can use it for text generation, and it's not like this one's just behind a closed door and you can't access it at all.
Okay, good.
But the more fun one is models like BERT and all the ones that are available through the Transformers package from Hugging Face. So Hugging Face have done a lot of work to try and, I think, democratize and make available a lot of these models in this current generation. And they have huge numbers of tutorials that allow you to fine-tune them for a whole bunch of processes. So just last week, I was playing with a tutorial on how to fine-tune one of the models. It's called Distill BERT. It's basically a smaller version of BERT. And
Okay.
Get it to be able to do this sentiment analysis. So it's like super straightforward. If you don't have like a computer that's powerful enough to run it, most people run it through Colab. And basically the notebooks are just set up ready for you to go through. So it's super accessible. I think it's really exciting because when BERT first came out, I remember it was really confusing how to use it. Like the model was available, you could generate predictions from it, but there wasn't really much in the way of documentation. But now it's just like,
okay,
you have too much almost. Like it's a bit overwhelming.
Well, yeah, I just went to the page and I'm looking at it and I'm just in like one tab of Transformer notebooks.
Yeah.
And it's huge. There are lots and lots of examples. That's great.
Yeah.
And then Colab is kind of, again, you're using other people's computers, which is kind of nice for that. So you can kind of play around in it. But just even, the fact that there are, I don't know how many tabs, it gets into a lot of the details we talked about, like, text classification, token classification, question answering, modeling of languages, translation. There's so many kind of directions you want to go. I spent some time, I had somebody on from Dolby, and we were talking about audio. And so there's actually some stuff in here, which it's interesting to think about like how that connects, but audio classification and automatic speech recognition. So yeah, it's like, wow. Okay.
Yeah.
If you want to play, this is a great resource.
Yeah. And I think this is one of those things that I would say, look, don't be intimidated. Don't worry about all the theory because it is a bit dense. You don't need to understand it all. You really just need to understand that what you're starting with is a general purpose model that's designed to model language. And what you're trying to do is to tune it for a specific purpose. So again, don't be overwhelmed or feel like you need to like understand the architecture of transformer models inside and out. It's just, again, Python is pure love and it makes it super easy to do.
Yeah, that's nice. Yeah, I'm excited to come back and play with some of these. I didn't know there were so many resources.
I know. I think I actually didn't realize there were so many resources until I was looking around to like put stuff together for the podcast. And I was like, holy moly, like this has changed quite a bit since last time I looked at it.
Good.
So yeah, maybe we can sort of round out by just having a discussion about Copilot, but I don't think I really want to discuss it that much from an ethics point of view. We can sort of touch on that, but more from, I guess, an applications point of view, because I think this is one of the most well-publicized applications of GPT-3 that I've seen.
Yeah, and it's definitely coming up all the time in conversations about, developers and Python and so forth. And I got my invitation finally.
Oh, yay.
so I can play with it if I want.
Yeah.
I haven't quite yet. The pricing is interesting. Again, we can get out of the ethics of that and so forth, but there's been lots of conversations on that.
Yeah.
And I mentioned this to you before our previous episode. One of the funnier things that I saw was this sort of auto completion thing that was happening. Somebody was looking at JavaScript and they were looking at like a comment string. And so they typed out like, I don't. And then they were looking at all the different ways that it was auto-completing it. Kind of the way Google would do that for you for, kind of auto-completing the different directions you could go, the vectors, if you will. And so it was like everything from like, I don't know what this does to I don't know if I want to do this anymore. So these are comments in people's JavaScript code. It got dark.
Yeah.
So I don't know if I could find that link, that tweet. I'll include a link to it. But yeah, it's interesting because it's based on GPT-3. So it's sort of inside the, if you will, Microsoft umbrella.
Ecosystem. Yeah, kind of. So yeah, OpenAI is not owned by Microsoft, but they have invested heavily in them. So, and obviously assisted them with the computer. So yeah, basic.
And then GitHub is a subsidiary now, right? So
yeah. So all part of the same family. So yeah, it's a model that was a fine-tuning of GPT-3 called OpenAI Codex. And they took a whole bunch of publicly available code on GitHub and other code from other places and just used it to teach GPT-3 how to generate code. And it's actually interesting because if you, again, play with the endpoint of GPT-3, you can actually generate fairly decent Python code. It's kind of amazing. So there's a very well-known tutorial in machine learning it's not a tutorial, it's a dataset called the Iris dataset. And
I've seen that before.
Yeah. So basically, I think the prompt I typed in was, you basically type it in like a doc string, and I typed in create a classifier using the Iris dataset, and it generated the entire thing. I was just like, and that was with GPT-3. That wasn't with Copilot or OpenAI Codex. So I was like, whoa.
Yeah, pretty wild.
Yeah. Although there was another one I tried that was more complicated, and it generated comments that said, insert your code here. It's like, helpful, thank you.
Yeah, they included the ... for you.
Yes, exactly. Thanks, I'll do that.
Yeah, I mean, not to completely go off on another tangent, but the idea of it, being this, if you will, general purpose is you can aim it in other directions. So like you said, this could be aiming it toward code and specific, languages. I would guess, as you type in a particular style. I haven't tried it yet. And again, I guess by naming the file type that you're doing, it's going to, choose its choices of how to answer here. But I found this article that was talking about how to do the same thing toward like it solving math problems and, like train it on, mathematical papers and so forth, and kind of seeing what they can kind of get out of it. And I mean, that's what's very interesting about all this, is that it is a direction of research. It doesn't have to be words or just identifying sentiment or things like that. You could be using it for the generative purposes or classifying other things. And I don't know. I'm intrigued by it. I've thought about it a lot of times toward music.
Yeah,
most generative music has been pretty terrible that I've heard. There are some really neat things I've heard lately where they've gotten some interesting stuff. Like there's this program that I really like called Reason. That's a software tool, and they had this thing called the baseline generator. And the idea is, if you're a musician and you're like a guitarist or a keyboardist, probably one of the hardest things to do outside of getting drums is trying to figure out what a bass player would play. And usually what you end up doing is really simple and generic, and you're like, play the root note, and it ends up being really boring. And this thing analyzed how all these different players might play a certain type of music, and then you can kind of dial in what you want. You can choose, do you want it to be more on key or off key? So again, kind of getting that parameterization of it. And I was just impressed. And I don't believe it's using things like machine learning. I think it's more been kind of their own way of ripping apart like all these performances and kind of thinking of like where things land. But it's interesting, like that all these tools are sort of kind of coming out recently. I mean, we didn't even get into it, but is there a relationship between some of this and the artwork stuff?
I'm so glad you asked. I was just about to mention that. So yes, DALL-E, this like amazing new like image generation. It's also a transformer model.
Oh, it is transformer. Okay, that makes sense.
Yeah. So people are touting like big things for the future of transformer models. I can totally see it. I'm on the wait list for DALL-E too. I really want to get access.
Yeah, it's interesting. The stuff I've seen from it. Lots of weird little examples.
Yeah. I kind of feel like the DALL-E prompts say more about psychology than they do about machine learning.
Yeah.
I love them.
I mean, I guess you could do that. Analyze what are people entering into here,
Oh my God, I could fine-tune GPT on DALL-E prompts.
Yeah, definitely.
Yeah.
Now we're back to cats again.
We're back to cats. Always comes back to it.
Cats and dogs.
But yeah, like one of the reasons that I guess I wanted to get into Copilot and like have you bring up these sort of math paper refinement is like, I think this can get people's imagination really fired up about what you can do with these models. And like they're very powerful tools. And again, you just have them there. You can just use them in this Transformers package and it's not that complicated. So yeah, like get excited if this sort of stuff interests you. It's very accessible.
Cool. And so again, if you haven't dug into our show notes in the past, please come and check them out. We have lots and lots of links either on realpython.com/podcast, or if you have a player, and it's nice to know that things like Spotify and most of the other good players have the show notes in there, so you can kind of check out the links. I know that probably looking at them from your phone inside like a phone, the player's browser is not the best, but the links are there. Please check them out. And what I wanted to do is maybe think about these are the types of topics that we'd like to kind of dig into a little bit more. If there are areas that you're interested in us exploring more, let me know. I've been getting lots of really great communications through the website, and it's been helping me kind of figure out directions for the podcast. And please let me know. I have a few more listener guests coming up in the future. I have an idea for doing one about some of the projects that people are working on, which I think is a great way to kind of share what the community's doing with this. I know that a lot of this is newer. Were you using any of these tools in your previous job? Like, were you using BERT or any of the GPT versions in the tools that you were developing?
So yes, not GPT, but basically I worked on a project. It was pretty cool, actually. So pretty much what we were trying to do was to generate a kind of ontology, like a database of words that were relevant to search in the job sphere.
Yeah, the job one. Okay, cool.
Yeah. And so, we had a team of very talented linguists building this manually, but we wanted some way of like getting terms in faster, like, blockchain or Rust developer sooner than they could manually add them. So what we were thinking of doing was building some sort of, vector space which contained all of these words and their relationships to each other. But using word2vec wasn't really feasible because, same word always collapses on the same meaning, and the models don't know what to do with new terms. So we're experimenting with BERT actually to try and represent terms and get their relationships to each other. And we did a POC, but I left before the project, developed a little bit further.
Okay. So you're involved in some of the early legwork, kind of researching how this might connect things together. That's cool.
Yeah. It was a fun project, actually. Yeah.
Nice. Well, last time we left off talking about some of the talks and things that were coming up. Maybe we could just do a general, how can people follow the things that you do online?
Yeah, so I'm very active on Twitter. So my handle is T_redactyl. Yes, I was obsessed with dinosaurs as a child. And yes, I do think Jurassic Park is one of the greatest movies ever made. And I also have a blog, similar name, so t-redactyl.io. So I'm guessing we can just share those in the show notes because
absolutely.
The spelling's a bit ridiculous. So I have actually quite a few blog posts about natural language processing tasks, how to use Word2Vec in particular. So yeah, feel free to rummage through my archive. Let me know if there's anything interesting.
Cool. Awesome. Well, Jodie, thanks again for coming on the show. It's always fun talking to you.
Yes, I really enjoyed my time, and thanks so much for having me on.
I want to thank Jodie Burchell for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.